So far in this lesson, we talked about how to work with exponents if they're fractional exponents. We looked at problems like that. We have talked about what to do if they are negative exponents. You write them as positive exponents and then solve. I did say since the denominator is only one term, you could move it up and use the distributive property, but you need to make sure that you reduce it correctly after that. They still want your answer written as one fraction.
Are you recording?
Yes, I am right now.
Okay.
And then, well, we just talked about how fractional exponents are the same thing as roots. So those are just some examples of what we've looked at. So now what we want to look at is we want to look at radicals and how we can simplify radicals. Now, when you take the square root of a fraction, you take the square root of the numerator over the square root of the denominator. So if I were to look at this particular problem, we could simplify it by writing it as 3 and then separate that fraction underneath the radical sign into two parts. The square root of the numerator over square root of the denominator. Minus 4, so I can show the next one is radical 2 over radical 3, plus 2, and then the square root of 24 is the same thing as, I don't know, 2 times 2 times 2 times 3. Let's say that. Now there's two different routes you can go from here. One thing you could do is you could just go ahead and get a common denominator, which personally I think is easier. Or the other thing you can do is you can rationalize the denominators and then add your fractions together. But if we're adding fractions, I like to go ahead and just get a common denominator. I will show you both ways. Can I just go ahead and simplify this last one? What's it going to simplify into? 4 radical 6. So I'm just going to go ahead and change that to 4 radical 6. Okay, so if we look at the two different methods used in order to solve, the first thing that I said is you could go ahead and you could take, let me do this. Let me just group this and repeat it, and it's going to be easier than trying to write it down now that I got my clone. There. So the two different methods that we're going to use in order to solve this. The first one that I like is if we were to just go ahead and take that problem, get a common denominator, because that's what we're doing. We're adding fractions together. So I'd multiply the first fraction times radical 3, the second one times radical 2, and that common denominator is radical 6, so I need to multiply numerator denominator of the last fraction by radical 6. Is everybody okay with that? It's just getting the common denominator.
Kind of like that one thing where you.
So if we look at the first term, what's the square root of 3 times the square root of 3? 3. So 3 times 3 is 9. Your second fraction, radical 2 times radical 2 is just 2 times 4 is 8. And the last one's going to be 24. That common denominator, remember if you're adding fractions and they have a common denominator, you just add or subtract the numerators and put it over that common denominator. So that simplifies into negative 23 over radical 6. Now mathematicians don't like the radical in the denominator. UNL placement exam would probably have this as an answer, and they would keep it that way. Saxon says let's get rid of the radical in the denominator by rationalizing it. And your answer ends up being negative 23 radical 6 over 6. And they say there's your answer. Question. The other method, and you can decide which one you like better, the other method would involve rationalizing the denominator first. So if you rationalize the denominator first, you would multiply by radical 2. You would multiply by radical 3. Then you get 3 radical 6 over 2 minus 4 radical 6 over 3 plus 4 radical 6. First step, rationalize the denominator. The next thing that you would do is get a common denominator. So you'd have to take the first fraction times 3, the second fraction times 2, and the last fraction times 6. When you do that, you get 9 radical 6 minus 8 radical 6 plus 24 radical 6 over 6. And if you group those together, since they all have the same radicand value, you can just add the coefficients and you get 23. Oh, 25. Should it be 25 on the other side? Oh, why did that sign right there become a, that's my bad. This sign right here, I'll highlight it. That was my bad. This sign right here should have been a positive. See that? Sorry about that. I apologize. So that does make this right here. I need to turn this to a positive right there, which does make that 25 radical 6. And that right there should turn to 25. So yes, over here, when we group those together, we end up with 25 radical 6 over 6. Same answer, I don't care which way. And why do I have a negative right there? That should be positive. Yes. So you get the same answer either way. I don't know yet. Thank you. So you either rationalize the denominator first, which is this method over here, or come up with the common denominator. I don't care which way. Pick which way. I suppose you want to practice with one like that on your desktop.
I got you.
Forgot to record all that. I'll back up and state it real quick. No, that's recorded. So you take this, separate it, make sure you take the square root of 9. Right there?
Oh, 3 times 3, okay.
Yeah. So write it into your separate fractions and then go ahead. The square root of 9 is the same thing as 3. So then you get 3 radical 2 over 3, but the 3's cancel. So the first term's just radical 2. The second one is just 9 over radical 2, and then you get minus 20 radical 2. Okay, so it looks like this. The square root of 2 plus 9 over radical 2 minus 20 radical 2. Your common denominator is radical 2, so you multiply the first fraction and the last fraction, which gives you 2 plus 9 minus 40. Radical 2 times radical 2 is 2, times 20 is 40. Hopefully I got all my signs correct this time. So if you subtract, you're going to end up with, I believe, negative 29 over radical 2. I'm going to check my math now. So then you get negative 29 radical 2 over 2 if you rationalize that denominator by multiplying by radical 2. If you could reduce the 29 and the 2, you would, but you can only reduce the numbers outside of the radical sign.
But those 28 is
Yes.
14, right? Why did it
Yes.
squirt rag and a squirt ball?
Yes, if it were 28, that's what it would be. Okay, if you do the first step, I just split the radicals into 2 separate ones, the fraction into 2 separate ones. 240 is the same thing as 24, which is 3 times 8, or 3 times 2 times 2 times 2, and 10, which is 2 times 5. So you have 2 pairs of 2's. You're going to multiply those 2's together and take it times the 3 to give you 12 radical 15. Now, something else that I would probably do within this step is I would simplify the square root of 12. So the square root of 12 is 2 times 2 times 3. So I would write it as 2 radical 3. You don't have to, though. I mean, you can leave it as radical 12. You're just going to be working with larger numbers. I don't care. If you leave it as radical 12, you're going to, did you get a common denominator?
Yeah.
Yeah. Multiply by the square root of 5. Multiply by the square root of 12. Now, this is where you get into that part. I'm just going to leave that for a second. Because I'm going to, well, I don't care. We could take it times this. Did you take it times the square root of 60?
No, I think I'm going to 5. Are we allowed to do that?
You can, yeah, you can just show it as 5 times 12. Because we're going to simplify, so we're going to take out factors. So if you look at it, 5 times 5 is, or radical 5 times radical 5 is 5, times 3 is 15.
Yeah.
Everybody okay with that part? And this one was radical 12 times radical 12. 12 times 3 is 36. Now, if I just focus on this right here, you don't see, it's not as easy as a radical times itself. So if you look at that, you have the square root of 15 is 3 times 5. Then you have 5. And then you have 12, which is 3 times 2 times 2. Would you agree? So you have a pair of 3s, you have a pair of 5s, and you have a pair of 2s. So this becomes 2. This becomes 5. You multiply those together and you get 10. This becomes 3. So you have 30 that you're going to pull out. So you're going to take 30 times 12, which is 360. And that's over. Now you have to simplify that denominator. So you get the square root of 60, or 5 times 12, which is 2 times 2 times 3, which you bring out the 2's. So you get 2 radical 15. Question on any one of those values? I'm not done yet. So you get 36 plus 360 plus 15. What is it? No. 375 plus another 36. 4 something. 416.
That's 396 plus 15.
So you get something that looks like this.
No.
Then you can take 416 and divide by 2. You what? No. What did?
I got 411, but I don't know.
Oh, no. I think you're right. 15, I got to shift my 5 over. It should be, you're right. You're right. Plus 15 there. So you're going to get 10, 11, 411. Oh, darn. Now that doesn't simplify as easily. What you know? No, that's still not that bad to simplify. Just take it times radical 15. So you're going to end up with 411 radical 15 over 15 times 2 is 30, but that does not reduce. So you can leave it in that format. Oops.
It was really like fold up the package to get it in a box. Like it was like up to.
There we go. Go ahead and try that one. Here we go. If we go through and simplify, you have 5 radical 2 over radical 9 plus 3 radical 9 over radical 2 minus, is that okay if I look at 8 as 2 times 2 times 2 and say it's 10 radical 2? Everybody okay with that? Now I'm going to show you two different ways to work through that from that point, because some of you are, come on, some of you are going ahead and simplifying your radicals. Come on. If you simplify your radicals, you're changing the square root of 9 to a 3. If that's the case, your problem now becomes 5 radical 2 over 3 plus 9 over radical 2 minus 10 radical 2. What is the common denominator? 3 radical 2. So I have to multiply the first fraction times radical 2. I have to multiply the second fraction times 3. And I have to multiply the last one times 3 radical 2. When you do that, your first term becomes 2 times 5, which is 10. Your second term becomes 27. And your last term becomes 2 times 30, which is 60. I missed a sign again. Okay, so 10 plus 27 is 37. You subtract 37 from 20 or from 60 and you get negative, I believe, 23. Now you want to rationalize the denominator, so multiply by radical 2. And you're going to get negative 23 radical 2 over 3 times 2, which is 6. And 23 and 6 do not reduce. Now, the other thing you could do is you could just come over here, and people get in this habit, and they just start multiplying by the radicals. So I got to multiply this times radical 2. I have to multiply this times radical 9. And I have to multiply this times radical 9, radical 2. That's okay. You're okay if you do that. Right here, what are you going to get?
2.
You're going to get 2 times 5, which is 10. The next one, you're going to get 9 times 3, which is 27. And the next one, you have a pair of 2's here. So you get 20 times, and this right here has a value of 3, which is going to make it be 60. Over the square root of 9, which is 3 radical 2. Now you go through and you're going to get negative 23 over 3 radical 2. You rationalize the denominator. And you get back to negative 23 radical 2 over 6. What's your answer? Okay, try this one. 2 radical 3 11ths minus 5 radical 11 thirds.
I'll learn everything.
You catch the other. All right, separate it, and then you're going to multiply. I'm guessing, did you get a common denominator?
Yeah.
All right. That seems to be the method of choice before rationalizing the denominator. So the numerator becomes 6 and negative 55 over the square root of. Those are already in prime, or they're both prime numbers. So it's just going to become the square root of 33. So if you subtract, you end up with negative 49 over the square root of 33. And if you rationalize the denominator, you end up with negative 49 radical 33 over 33. 3 does not go into 49. Sum of digits is 13. 3 doesn't go into 13, so that is reduced. Okay with that? All right.